Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Hello. Oh, there I am. Lesson 18, Similarity and the Angle Bisector Theorem. Classwork, opening exercise. Exercise, that means do it yourself. Pause the video, see if you can answer these 3 questions, and then come back and we will fill them in. Okay, so here we go. Part A, what is an angle bisector? We know what an angle is. We know what bisecting means. It means to cut into 2 equal pieces. So the bisector of an angle is a ray in the interior of the angle such that the 2 adjacent angles formed by it have equal measures. So if I have a ray, that's not a ray. I thought I chose ray. Okay. If I have a ray and it is going like that, and then another ray going this way, then the bisector would be another ray that would go in between, just like that, so that this angle here would be equal to this angle here. So if the whole thing was 40 degrees, then this would be 20, and this would be 20. Okay, so a ray in the interior of an angle such that the 2 adjacent angles formed by it have equal measures. Simple enough. Okay, moving along, part B. It says to describe the angle relationships formed when parallel lines are cut by a transversal. So when parallel lines are cut by a transversal, the corresponding alternate interior and alternate exterior angles are all congruent. The same side interior angles are supplementary. So what they're saying here is, let's get a line and another line that are parallel, and then cut it by a transversal. There you go. Parallel lines cut by a transversal. Then this corresponds with this. Alternate interior would be angle 1 and angle 2. And alternate exterior. So let's call this 3 and this 4. So angle 3 is congruent to 4, they're alternate exteriors. Angle 1 is congruent to 2 because they're alternate interiors. Angle 3 is congruent to angle 2 because they correspond, and they're all congruent. Same side interior angles are supplementary. So if I chose this angle here, along with this angle down here, let's call that 4. Angle 2 plus angle 4. Angle 2 plus angle 4 would equal 180 degrees. Okay, so that's what that one says. And then finally, and let's get these out of the way here. What are the properties of an isosceles triangle? So an isosceles triangle has at least 2 congruent sides and an angle opposite to the congruent sides. The base angles are also congruent. So if I form a triangle like so, let's make it obvious that the 2 are congruent and the third one is not. So what this means is, if this side is congruent to this side, so let's call that A, B, C. If AB is congruent to BC, then the measure of angle A that is opposite BC and the measure of angle C that is opposite AB are base angles, and they are congruent. Okay, so there's that. Discussion. In the diagram below, the angle bisector, notice the term they just used, the angle bisector of angle A which means this angle is congruent to this angle, in triangle ABC meets side BC at D. So this ray right here is a bisector of the angle CAB or angle BAC, whatever you want to call it. Does the angle bisector create any observable relationships with respect to the side lengths of the triangle? Okay, so here's what we know. We know that when that happens, BD is to CD equals BA at CA. So if BA, in this situation, if BA is 12, BA is 12, CA is 6, that's a 12 to 6 relationship, or reduce that to 2 to 1. So if BD was 8, then half of 8 is 4. Notice they have 8.08, 4.04. And BC is 12.12 total. Okay? So the opposite side cut by a angle bisector is proportional to the two other sides. So again, AB is to AC as BD is to DC. Okay, page 2 brings us to exercises. So there's 2 on this page. Pause the video, see if you can do these 2, and then unpause and see if your answers match mine. So here we go. Exercise 1 through 4, the sides of a triangle are 8, 12, and the whole thing, BC, is 15. An angle bisector meets the side of length 15, BC that is. Find the lengths of X and Y. Explain how you arrived at your answer. Okay, so keep in mind that we have a proportional setup, so that let's call this A, B, C, let's call that D. So I can set up a proportion. So I can say BD is to DC as AB, and the word as, I suppose I could use equals. AB is to AC. Okay, so let's fill in our information. AB is 12, AC is 8. 4 will go into 12 3 times, 4 will go into 8 2 times. So we have a 3 to 2 relationship. BD is Y. DC they labeled as X. So Y is to X is 3 to 2. So let's see, how could we do this? We could say X plus Y equals 15. Okay, so we're going to use algebra here. And Y is to X can be written as a fraction, Y over X equals 12 over 8. And when I cross multiply, I get 8Y equals 12X. Okay. The other thing I can say is X is equal to something. So if the whole thing, all of this is 15, and I subtract Y, I get X. 15, like say Y was 9, 15 minus 9 is 6. 9 plus 6 is 15, agreed? Okay, but we don't know that yet. So we can just say X equals the whole thing minus the other piece. So let's say 15 minus Y. And I'm going to do that in a different color. How about red? And the reason I'm doing that is because I'm going to substitute in now. So when I simplify this, I'm going to substitute in for X. So I'm going to say 8Y equals 12 times my X, but my X is 15 minus Y. The reason I did this is because we can't solve an equation with 2 variables. two unknowns we can't solve. But if we substitute in something we know in another term, then we can narrow it down to one variable and we can find y. So when I do this, I'm going to bring down my 8y equals 12 times 15 is 180 minus 12 times y is 12y. Okay, so then I add 12y to both sides and I get 20y equals 180. So in solving for that, we're going to take 20y and divide it by 20 equals 180 divided by 20, and we're going to get y equals 9. Okay, so once we find 9 to be y, I can plug it in here. So x equals 15 minus 9, because y is 9, we can then substitute in. And so therefore x equals 6. So y is 9 and x is 6. To answer that, and then we could also do it this way, 6 comma 9, since it's x and y. But we're not graphing, so I suppose we wouldn't want to do that. So the length of x is 6 and the length of y is 9. Reason? Since I know that A is bisected, I applied that I knew about the angle bisector theorem to determine the length x and y. Specifically, the angle bisector cuts the side that is opposite the bisector angle so that y to x equals 12 to 8. I set up an equation using the values of the ratios, which could be solved once I rewrote one of the variables, x or y. You could have done both or either. I rewrote x as 15 minus y and then solved for y. Once I had the value for y, I could replace it in the equation x equals 15 minus y to determine the value of x. Okay, number 2. The sides of a triangle are 8, 12, and 15. So 8, 12, and 15. An angle bisector meets the side length 12. So this bisects this. So these two angles are congruent. This is bisected. So it says find the length of x and y. So as above, we can say x over y equals x over y. And notice up here equals, so x went with 8. Notice on the same side of the bisector, we put this over this, y over 12. Okay, right here. Or you could say x over y, 8 over 12, or y over x, 12 over 8. Any proportional setup works. So if I said x over y, then I'm going to say 8 over 15. Because those are the two on the same side of the bisector. X goes over y, 8 over 15, or we could have done it y over x, 15 over 8. Cross multiply, and we get 8y equals 15x. Now we need to solve for either x or y. It doesn't matter which. I will just pick, how about we solve for x? So I know that x is the total minus the other piece. So off to the side here, I'm going to say x equals 12 minus y. And when I do that, I can substitute in for x. So this is going to become 8y equals 15 times, instead of x, x equals 12 minus y. So I substitute in the y equivalent of x. And then I get 8y equals 15 times 12, which was 180, and minus 15y. When I add 15y to both sides, we're solving for y. I get 23y equals 180. Divide by 23. And y equals, let's save some time here. 180 divide 23, and we get 7.82. Is that right? Let me check my work. Okay, I'm going to leave this. So I brought this up on my calculator. You don't want to use decimals and round because it's not accurate. So I'm going to erase that. And we're just going to leave it, and it doesn't reduce because 23. So we're just going to say y equals 180 over 23. But that would be 7. What's 23 times 7? 161. So that'd be 7. And 161, that'd be 19 remainder. So it'd be 7 and 19 23rds. So if I didn't want the improper fraction, we can change that to 17 and 19 23rds. Okay, so once I get that odd amount, whoever made this problem didn't do a very good job choosing values, because when I have a new concept, I like to use integers. But anyhow, we'll continue. So now we know what y is. We have to find x. So x equals 12 minus y. I'm just bringing this down. And now I'm going to substitute in my y. So x equals 12. And I'm going to use this value, it's just easier. And I want the common denominator of 23. I cannot subtract fractions unless the denominator is the same. So 12 times 23 is 276. So I can represent 12 as 276 23rds minus our 180 over 23. So x is going to equal 276 minus 180, which would be not quite 100, 4 shy of 100, which is 96. So x is 96 23rds, which equals 4. 96 divided by 4 is 24. Whoops, 96 divided by 23 is 4, and 23 times that 4 will give us 92, so that's a remainder of 4. So it's going to be 4 and 4 23rds. So x is 4 and 4 23rds, y is 7 and 19 23rds. Okay, not very pleasant numbers to work with, but there it is. Okay, page 3, exercise 3, pause the video, see if you can do this, and then here we go. So the key to this is they give this the side lengths, the whole thing, 8, 12, 15, and an angle bisector. That's the key here. If this is bisecting, then we can set up the proportion. Meets the side AB, or AC, I mean, length 8. Find x and y. Find the lengths of these two pieces. Okay, so we have 12, we have 15, we have x, we have y. So I like working on the same side. So I'm going to compare these two, and I'm going to compare these two this time. So see if it comes out the same. So I can say 12 is to x as 15 is to y. Cross multiply, 12y equals 15x. And then off to the side, I can solve for either x or y, it doesn't matter. It's just the total minus the other. I'll do y this time just to be different. Y equals 8 minus x. This piece equals everything minus the other side. So now I can substitute that y in over here. So I would get 12 times 8 minus x equals 15x. 12 times 8 is 96, minus 12 times x is 12x, equals 15x. 96 equals 12x to both sides. I'm going to add, and that's going to be 27x. Divide both sides by 27. It's not a pretty number. It's a fraction, but that's okay. We need practice with fractions, I guess. 96 divided by 27 equals 3.5, repeating. Okay. And I can do math, enter, and it will tell me the reduced fraction, 32 ninths. And if I don't want it mixed, which my answer will be a mixed fraction, I don't want it improper. 9 times 3 is 27 with a remainder of 5, 3 and 5 ninths. Okay, but I'm going to use this value to find y. So y equals 8 minus 32 over 9. Multiply 8 by 9. Okay, 9 times 8 is 72 over 9 minus 32 over 9. And y is going to be 72 minus 32 is 40 over 9. And when I don't want mixed, 9 times 4 is 36, remainder of 4. So x is 3 and 5 ninths, and y is 4 and 4 ninths. Number 4, the angle bisector of an angle splits the opposite sides of a triangle into lengths 5 and 6. The perimeter of the triangle is 33. Find the length of the other two sides. So in geometry, you need to get into the habit of drawing triangles. Use a ruler, please, because I have so many students who draw triangles and they look like this. Please do not do this for your teacher. Do not do this. Okay, looks like the state of New York. Okay, use a ruler and draw nice straight lines. So I'm going to use a ruler myself. And it's always good to draw a diagram. Okay, it doesn't matter that it's not to scale. Just draw a triangle. Don't make it equilateral. Okay, there's a triangle. And then fill in the givens. So we have an angle bisector. So I suppose I should draw that. Let's just bisect this one. Just approximately, it doesn't have to be exact. Let's just say that cuts the two sides in half, but not necessarily equal pieces. An angle bisector of an angle splits the opposite sides into lengths 5 and 6. So this one looks shorter, so I'll put 5 there and 6 over here. The perimeter of the triangle is 33. Find the lengths of the other two sides. So this whole side, obviously, is 11. Okay? So there's our diagram. We know that this angle is congruent to that angle because it's an angle bisector. So here's a triangle. The perimeter is 33. In other words, x plus y plus 11 equals 33. That's what we're given. The three sides add up to 33. So I know that x plus y equals 22. And we also have this setup. We can say 5 over y equals 6 over x. 6y equals 5x. Cross multiplying. Okay. And over here, it doesn't matter. I can solve this for x or y. And if I subtract x over to the other side, y would equal 22 minus x. So this is what I'm going to use. 6, instead of y, I put 22 minus x equals 5x. Distribute. 6 times 2 is 12. Carry the 1. That's 132 minus 6x equals 5x. 132 equals, add 6x to both sides. We get 11x. Divide by 11. And x is going to equal 1. 11 goes into 13 once, the remainder 2, and 22, it'll go twice. X is 12. So I know x is 12. So to answer this question, I can now use this equation. Y equals 22 minus x. So y equals 10. And then I check. What's 10 plus 12? 22. What's 22 plus 11? 33. The perimeter is 33. We're done. X was 12, Y was 10. Okay, page 4 brings us to the end of lesson 18, a nice short lesson on angle bisectors. Go to your problem set.